All right, here we go. We got number 5 here. We got a cylinder going on, and your cylinder formulas are pretty straightforward here. So for a lateral area, we usually do the circumference, which is 2 pi r, and then times the height. For surface area, we'll go 2 pi r times the height, but then we'll add on 2 of the bases. The base of a cylinder is just pi r squared, so we'll do 2 of those, 2 pi r squared. Okay, and then the volume is just going to be the area of the base, pi r squared, and then you will multiply that by the height right there. And those will be your formulas. So really the only dimensions that you're going to have for a cylinder are just going to be the radius and the height. The radius is right here. The height is the distance between your two bases, which happen to be circles here. So we're going to go and take everything and start plugging it right in. Let's see, I guess I'll plug it in down below. So this one here will be 2 times pi times 4 for the radius, and then the height I believe was 7. Now when you're typing this into your calculator, if you're doing the mental math, basically you're going to leave pi in your answer. So I'm just really thinking of what's 2 times 4 times 7 right there. And then we'll punch that out. 2 times 4 is 8. 8 times 7 would be 56. So we'll put 56 pi, and then the units were in inches, so we'll say inches squared right there. And that'll be your answer there on that. Okay, that was lateral surface area. Now we will do the total surface area. So plugging in the same things here, 2 pi r, so 2 times 4 times 7. Sorry, that 7 looks really bad there. Okay, and then 2 pi, and then r squared. R was 4 again. So we're still going to get 56 pi here for this first part. Then after we do 4 squared, that's 16. 16 times 2 should be 32. So we'll go and add those dimensions up. And I believe, was that 88, I believe? Yeah. 88 pi, and then inches squared again. And that'll be your answer. Okay, and then finally here at the end we got pi r squared times h. So let's try that out. R was 4, h was 7, and 16 times 7, that's going to be a little bit big there for me. That comes out to 112. So we will write this as 112 pi and then inches squared, or inches cubed, I'm sorry. And yeah, that's your answer there. That's pretty straightforward. Just be careful. A lot of people will want to use the pi button, which you can get if you want. For example, 56 pi, you would hit second and then raise to is your pi button. You can get the decimal, but I'm pretty sure our test is going to say leave in exact form or in terms of pi. So make sure you get all that and you should be good. Okay. Probably the hardest question that we will see here is the volume and the surface area and lateral area of a hexagonal prism right here. So that's a prism. So this one's a little tricky here. We got to remember how to get the area of the base for this here. So we'll need 3 things. We'll need the perimeter, we'll need the height, and then the hard piece is the area of the base. All right, so the perimeter is not too hard because it's the perimeter of the base and it's on its side, so the base is the hexagon. I'm going to color in this back hexagon because I'm going to do a lot of math here on this front hexagon. But that's, one of the bases there. And each side apparently is 8. So each side on the back needs to be 8. And you got 6 of those sides. So you're just going to go 8 times 6. And I guess that gets you 48 right there. And then I guess we need the height. The height's pretty straightforward. It's 6. The height is always the distance between your two bases. All right, and the area of the base. The area of the base for a regular polygon was this formula we learned a couple units ago. It's 1/2 the apothem and then times the perimeter. The apothem piece is from the center straight down. It's a perpendicular bisector. Let's try that again. It's a perpendicular bisector. So we have a whole unit going over this here. So I'm going to kind of go through it quickly. I'm going to assume you remember some of the steps on how to figure out everything with that triangle. The apothem's right here. So we need to find that right there. We already had the perimeter, so that's all we're finding right there. Now, if the full side of the entire hexagon side is 8, then this half side right here is going to be 4 on that triangle. To figure out the angle up there at the top, it's actually half of a typical central angle. So to find the central angle, we'll do 360 divided by 6 because there are 6 sides on a hexagon. So if we do 360 divided by 6, that gives us a central angle of 60 degrees, but then we take that 60 degrees and we divide it by 2, and that's going to get us 30 degrees inside of our triangle. Okay, and what's significant about that is it's going to be one of our special right triangles. Let me see if I can tighten that 30 up. Sometimes it's even best to maybe even just sketch you a brand new picture. Yeah, there's your 30 right there, your angle. So the typical ratios for these here is we say like, okay, if this is a side, then this side is the same thing, but then multiply by square root of 3. And if you do 2 times this side right there, that's going to be the hypotenuse. So look at this here. Our side apparently is 4 according to this, so that means the apothenpiece is going to be 4 times square root of 3, or just 4 square root of 3. Okay, so all of that to get this A piece right here. But now that we have that A piece, then we can go ahead and type it into our formula here. We'll go 1/2 4 square root of 3, and then times the perimeter, which was up there above, was 48. And that's going to help us find the area of the hexagon. All right, and then we will use all 3 of those pieces to go find the lateral area, surface area, and volume. Now, a couple ways you can do this. I'm not sure if your teachers are going to want you to round or keep the square root of 3 in your answer, so you might want to clarify with them. If you want to keep the square root of 3 in your answer, you're going to go 1/2 of 4 and then take that answer and do times 48. 1/2 of 4 is 2, and then 2 times 48, was that like 90 something, 96, I believe. So when you simplify this, you're just going to say it's 96, but then you still have the square root of 3, 96 square root of 3. Okay, now if you want the decimal form for that, you would just type it in 96 second and then square root 3. Apparently that's about 166 and then 0.277. Usually I like to go out a couple extra decimal places on these here, because the answers will usually say like nearest 10th or nearest 100th. So go out at least, to 1,000th place so your final answers are more accurate. So for the purpose of this problem, though, I'm going to use the 48, the 6, and I'm going to use the radical form there of 96 square root of 3. Okay, now once you have that, then we can go start plugging in those numbers into our formulas. The lateral area is just perimeter times height, which in this case is actually going to come out real nice. That's just 48 times 6. Okay, 48 times 6 apparently is 288. So we'll say 288. The units, I think they're in inches. Yep. So that'd be inches squared. Okay, for the surface area, pH plus 2b. Whoops, I'm drawing the wrong symbol there. Plus 2b. All right, so 48 times 6. Okay, and then you're going to do 2 times, what was it, 98 or 96. So 2 times 96 square root of 3, which really you just need to multiply the 2 and the 96. So 2 times 96 is 192 right there. So if you want to leave this in simplest radical form, this is going to be, 288 and then plus 192 and then square root of 3. Now that's not very convenient to say out loud. So most of the times on these, I think you're going to be able to do your decimal approximation. So you can just type it in the exact way it looks, 288 and then plus, 192 and then square root of 3. So that's apparently 620 then 0.55. Now, depending on where you round off your answers, if you use this 166 and you kind of rounded that different, you might get slightly off on your units, but more than likely that's going to probably be good enough right there. Okay, and then if you want to go and do your volume, volume's pretty straightforward because that's just big B times H. Okay, so in our case, that's, what was it, 96? Yeah, 96 square root of 3, and then times the height, which was 6. And what I'm going to do is I'm going to just do 96 times 6, and then I'll just attach the square root of 3. So that's 576 square root of 3. Or if you want to use the decimal approximation, you can just times that by square root of 3. And that's 997 and then 0.66. And then we would put inches cubed. And that would probably be good for your answer. I guess, if you want to go copy over your perimeter and base, perimeter is 48. I guess that would be in inches, and then the area of the base is 96 square root of 3 inches, or the 166.227. So yeah, kind of a longer problem. Those are probably the hardest type of problems on this test right here. All right, luckily the cone's not too bad. The cone has only got 3 dimensions that you need to find. Usually you need your radius. This is your radius. Here's your height. And then just like the pyramids, you need your slant height, which is that diagonal piece there. And we will typically use Pythagorean theorem for this, since it makes a right triangle. 6 squared plus 8 squared, and then equals L squared. 6 squared is 36, 8 squared is 64. I think that's 100. So then that means L is 10 inches in this specific case. Once you have that, then you can go ahead and start punching out your formulas. By the way, area of the base, that's just one of the circles right there. That's pi r squared. In this case, our radius was 6. So we'll just go, I guess, 6. Well, here, let's write it out the way it looks in the formula. Pi and then 6 squared, which is 36 pi. That would be in inches squared. Okay, for a lateral area, formula for that's a simplified form of this formula. You can go conjugate it if you want, but really it's pi r L. And the radius, again, will be 6. And then the L, I believe we got, yep, L was 10. So that's going to be straightforward. That's just 60 pi, and then inches squared. All right, for surface area, just need to go on and add on one of those bases. So you're going to go pi r L plus one of the bases, which is pi r squared. So you can go pi 6 times 10, and then plus pi times 6 squared, which is 30. Whoops. Which was 36. So what does that add up to? 96, I guess? 96 pi inches squared. All right, and then finally you have the volume, and that is going to be kind of like the pyramid version. It's 1/3 out in front, and then pi r squared, and then times your height. So that's 1/3 pi. Your radius, what was that again? 6. So 6 squared. The height, we hadn't used the height yet. The height was 8. Okay. Now I know 6 squared is going to be 36. And a third of 36, or 36 divided by 3, that's going to be 12. And then 12 times 8, there, I guess it would get you 96. Now don't get confused here. I know that is the same number for the surface area, but it's inches cubed, which is a totally different unit. And that's totally fine if you have different units. But sometimes, yeah, they'll come out as the same numeric value. Okay, got a couple easy ones coming up here. So what do we got here? For each of the following in the polyhedron created by the net. Let's sketch the 3-dimensional version of that right there. So I see that. That's a net. A net is a 2-dimensional representation of a 3D object. What I am seeing, I see 2 pentagons right here. And then I see 5 rectangles right there. So that lets me know that has to be a pentagonal. You can say pentagonal or pentagon. Pentagonal is probably the best, but then it's a prism. Remember, a prism has 2 congruent parallel bases. If you were to fold that up, the 2 bases should be congruent and parallel at the same time. Okay, as far as a sketch of a pentagonal, like an actual 3D version of this, it's kind of hard to draw. I'm just going to draw a pentagon, and then I'm just going to draw a couple of sides going up. And then, let's see if that kind of comes out here. It's a horrible drawing right there, but I think that would be enough to get you credit right there, pentagonal prism. We'll go ahead and continue here on to this next page. This next one here, you have some type of, it's kind of like, looks like a triangle, but they're not very circular. And then you have a circle right there. That's actually going to be a cone right there. And as far as how you draw a cone, I just draw a little circle, and then I draw from the edges of that circle going straight up to a point. And that's probably the best way to draw a cone right there. Okay, the next one here, you have 2 triangles and then 3 rectangles right there. So if you have 2 triangles, that's probably some type of prism, since they're the same shape right there. And since they're triangles, we'll call that a triangular prism. All right, and then as far as how do you draw that, I guess I would just draw maybe like a triangle kind of like this. I'd draw another triangle off to the side. That's pretty similar. And then I would just connect all the points. That's not the best looking picture, but it'll do. And that'd be a decent looking triangular prism. Not sure where that 3D shape went down there, but all right, last one here. You got 2 circles. Oh, I'm sorry, you got 3 more here. You got 2 circles and then just a rectangle. If you roll that thing up together, that should actually be a cylinder. And the cylinder, the best way to draw a 3D version of that is do 2 circles, or really kind of like ovals, maybe like flat looking circles there, and then connect the sides right there, and that'd be a good cylinder. All right, this last one, since you have a bunch of triangles, imagine you're folding that thing up together. It's actually going to be a pyramid. Now, instead of just saying a pyramid, we always name a pyramid off of its base. So choose one of these here to be the base. I like to do this middle one. That's a triangle. So we will call this a triangular pyramid. And then as far as the 3D shape, I would just kind of draw a triangle kind of like you were looking at it from the side. And then draw all of these here going to one point. That ought to do good. Some people will do like, if you can't see like an actual edge, they'll do like maybe like a little dotted line like that to help you kind of visualize it. So that'd probably be pretty good there on that.